Hello again, it's Mr. Wilson, Physical Science B, and in this video we're going to be looking at the two formulas that we have for velocity in waves. We're going to do some examples with each one of them, several examples. So let's review what the formulas are. There are two of them, as I've said. In first instance, I have this triangle, where v is the velocity, and it is equal to the wavelength times the frequency. And then I have my second equation, which says that velocity is equal to wavelength over period. I get the second equation because of the relationship between frequency and period. You may recall that period is an inverse of frequency. All right, so v is velocity, lambda is again wavelength, and t is period. All right, so there's the two formulas. Now the one question that always comes up is, well, how do I know which formula to use? If you take the time and write down what's given to you and what it is you have to find, you should be able to figure out which of these two that you're going to need to use. So let's try a couple and see how that works out. All right, so here's the first one. Find the velocity of waves with a frequency of 12 waves per second and a wavelength of 1.4 meters. All right, so what's given to me in this instance? I have this and I have this. So I'm given a frequency of 12 waves per sec, 12 hertz, and I'm given a wavelength of 1.4 meters. I have to find velocity. So which of those two formulas am I going to use? Well, I'm going to use the first one because it doesn't give me a period. It gives me the frequency, so I'm going to use that first one. So according to that equation, v is equal to f times lambda. I should probably be consistent and put the equation here so that you can see it. All right, so there it is. My frequency is 12 waves per sec, and my wavelength is 1.4 meters. And that results in a velocity of 16.8 meters per second. Let's take a look at another one. Find the wavelength of waves traveling at a velocity of 2.4 meters per second if they have a frequency of 3.7 waves per second. All right, so let's see what's given to us. We have a velocity, and we also have a frequency. And they're asking me to find the wavelength, so I'm looking for lambda. These three variables tell me that I'm using this equation again. Since I'm looking for lambda, this is the equation I'm going to use. So I plug in my numbers, 2.4 meters per second over 3.7 waves per sec. Do the math, and I end up with 0.65 meters per wave. So each of those waves is a little more than half a meter long. Find what you're given, find what you need, get the equation, plug it in. Straightforward UPSL type problems. Next, find the frequency of waves that have a wavelength of 0.2 meters and are traveling at 2.4 meters per second. So I have a lambda here of 8.2 meters, and I have a velocity of 2.4 meters per second. Since I'm finding frequency, I'm again using that first equation. So my triangle, I don't know, I'm having a problem with that. Is that again. I'm trying to find frequency. So frequency is equal to velocity over wavelength. Plug in the numbers. Run it through. 0.29 waves per second, which is equal to 0.29 hertz. Remember that a wave per second is a hertz. So these are relatively higher frequency waves. All right, let's take a look at another one. Find the velocity of waves with a wavelength of 1.2 meters in a period of 0.8 seconds per wave. All right, what are we given? Wavelength of 1.2 meters. Period this time is equal to 0.8 seconds per wave. And I'm trying to find the velocity. Since I don't have frequency this time and I have period instead, I'm going to be using the second velocity equation, which said that velocity was equal to the wavelength over the period. So V equals lambda over T. So 1.2 meters over 0.8 seconds per wave, which equals 1.2 divided by 0.8, 1.5 meters per second. Okay? Again, same format. Don't make it harder than it is. What's given? What do you got to find? What's the equation? All right. Find the wavelength of waves moving along at 3.6 meters per second with a period of 0.54 seconds. Alrighty, what's given? This time I have a velocity, 3.6 meters per second, and I have a period, 0.54 seconds. And I'm trying to find lambda in this case. My triangle looks like this. So according to this, lambda is equal to velocity times period. So I have 3.6 meters per second times 0.54 seconds per wave, and that equals 1.94 meters per wave. So they have a wavelength of almost 2 meters. Those are some pretty big waves. All right, one more. This final one, which I'm sure you've figured out the pattern here, will be using that second equation too. What's given to me? Find the period waves with a velocity of 2.4 meters per second and a wavelength of 5.3 meters. So I'm given a velocity of 2.4 meters per second and a wavelength of 5.3 meters. In this case, I'm finding the period. And like I've said, we're using the second equation to find the period. So period is equal to lambda over V. Lambda is 5.3 meters. V is 2.4 meters per second. So I end up with 2.21 seconds per wave. It's a long wave. All right. As I've said numerous times to you in class and on these videos, the best thing you can do is to follow this kind of a format when you're trying to solve these problems. Look at what's given to you, look at what you have to find the equation, and solve the problems. If you have any questions, you know where to find me.